Tonight, while you sleep, the moon will quietly vanish from the sky forever. No explosion, no warning, no dramatic farewell, just gone. And within hours, the consequences would begin cascading across every ocean, every coastline, and every living thing on Earth. Scientists have actually mapped out exactly what happens next, and the timeline is far more terrifying than any disaster movie has ever dared to show. What you are about to hear will permanently change how you look at that pale light hanging in the night sky above you. This is not a thought experiment borrowed from science fiction or a doomsday fantasy cooked up online. It is grounded in orbital mechanics, climate science, and biology, fields that have spent decades quietly studying exactly this kind of scenario. The moon is not decoration hanging in the sky for our enjoyment each night. It is an active, load-bearing piece of the system that keeps this planet stable and alive. Remove it and everything downstream begins to break. Before we pull the moon away, it helps to understand exactly what it is doing right now, at this moment. Most people think of it as a light source, something decorative hanging in the night sky. But the moon is working constantly, running systems that Earth depends on to stay stable and alive. Its gravity reaches across nearly 250,000 miles and grabs the oceans, pulling them into those familiar bulges we call tides. That tidal pull doesn't just move water, it drives circulation in the deep ocean, distributing heat and nutrients across the entire planet. The moon also acts as a gravitational anchor for Earth's axial tilt, holding it steady at roughly 23 degrees. That tilt is what gives us our seasons, our climate patterns, and ultimately our ability to grow food reliably. Without that anchor, the tilt would drift wildly over thousands of years. So when the moon vanishes, it isn't just darkness that follows. It is the removal of a planetary life support system that has been running silently for 4 billion years. The first thing most people would notice isn't an explosion or a shockwave rattling through the ground beneath them. It's silence, a strange, eerie stillness spreading across every coastline on Earth. Within the first hour of the moon's disappearance, the gravitational pull that has been tugging at our oceans for 4 billion years simply switches off. The tides, which have been rising and falling twice a day since before life crawled onto land, stop responding to anything but the sun, and the sun's tidal pull is less than half as strong as the moon's was. Coastal towns that rely on dramatic tidal ranges would suddenly find their harbors locked at a single, flat level. Estuaries that breathe with the tides, cycling nutrients, flushing salt, marshes feeding entire food webs, would go still almost immediately. The ocean isn't dead yet, but something enormous and ancient has just been switched off, and the water doesn't know what to do next. Most people think the moon's influence stops at the ocean's surface, but that assumption is completely wrong. The same gravitational pull that moves billions of tons of seawater also squeezes and flexes the solid rock beneath your feet. Geologists call this effect earth tides, and it's measurable, constant, and surprisingly powerful. The crust itself rises and falls by as much as 30 centimeters every single day because of the moon. That rhythmic flexing generates heat deep inside the planet, feeding the thermal engine that drives volcanic activity and plate tectonics. Without the moon, that subtle but persistent squeezing would simply stop, and the planet's internal heat budget would begin to shift in ways scientists are still working to fully understand. Over geological time, reduced tectonic activity could mean fewer volcanoes releasing carbon dioxide into the atmosphere. Less carbon dioxide means a colder planet, a thinner atmosphere, and a world that starts drifting away from the conditions that made complex life possible in the first place. The first night without the moon, something feels deeply, fundamentally wrong before you even understand why. The darkness is not just darker, it is a different kind of dark. The kind that presses against your eyes like a physical weight. Stars that were always there but invisible now blaze across the sky in staggering, almost violent clarity. The Milky Way stretches from horizon to horizon, a river of cold light that most living humans have never actually seen. It is breathtaking, and it is terrifying at the same time. Across the world, people step outside and feel an instinctive unease they cannot name or explain. That pale, familiar face has hung in the sky for every single night of human history. Every myth, every calendar, every love poem written under moonlight, all of it anchored to something that is simply no longer there. The sky looks fuller than ever, and yet it has never felt more empty. The damage wouldn't stop at the sky. Down on the surface, entire ecosystems would start coming apart at the seams. Hundreds of species have built their survival around the moon's light and its gravitational pull on the tides. Coral reefs, for example, synchronize their mass spawning events to the full moon with extraordinary precision. Without that signal, reproduction across vast reef systems would fall into chaos almost immediately. Sea turtles navigate by moonlight to find the beaches where they were born. Remove that light, and their ancient migration routes simply dissolve. In the ocean, the tidal zones that millions of creatures call home would go eerily still, stripped of the rhythmic flooding that keeps them alive. Even insects on land use lunar cycles to time their emergence and mating seasons. The moon isn't just a light in the sky for these animals. It is a clock, a compass, and a calendar all at once. Lose it, and the biological machinery of the planet starts skipping beats. Without the moon's gravitational drag, Earth would stop losing the rotational energy that has been slowing it down for billions of years. The planet would gradually spin faster, and over time, that shift would become impossible to ignore. Days would grow shorter, not by seconds, but eventually by hours, as the spin rate climbed without any break to hold it back. A day that once lasted 24 hours could shrink towards something closer to 6 to 8 hours in the deep future. That might sound abstract, but think about what it means for every living thing on the surface. Plants would have far less sunlight per cycle to complete photosynthesis, and animals tuned to circadian rhythms would face a biological clock that no longer matches the world outside. Wind patterns, ocean currents, and atmospheric circulation all depend on how fast the planet rotates beneath them. Speed that up, and you fundamentally rewire the engine driving Earth's climate and weather from the ground up. That faster spin doesn't just change how long a day feels, it rewires the entire atmosphere. The Coriolis effect, which is the invisible force that steers winds and shapes storm systems, depends directly on how fast Earth rotates. Push that rotation faster, and the Coriolis effect strengthens with it. Winds that once curved gradually now whip into sharper, more violent arcs across the globe. The jet streams, those high-altitude rivers of air that regulate weather across entire continents, begin shifting position and intensifying beyond anything in recorded history. Weather patterns that billions of people depend on for agriculture, water supply, and basic survival start breaking down almost immediately. Monsoons that feed 1 billion people in South Asia lose their timing and their reliability. Deserts expand where forests once stood. Storms grow more frequent, more powerful, and harder to predict with every passing week. The atmosphere isn't adapting to a new normal. It's fighting itself, and there are no winners in that war. Right now, Earth spins on a tilt of about 5 degrees, and that angle is what gives us our seasons. Without the moon's gravitational steadying influence, that tilt would not stay fixed at all. Over thousands of years, Earth's axial tilt could swing wildly between roughly 0 and 60 degrees or more. At 0 degrees, the poles receive equal sunlight year-round, and the seasonal cycle we depend on simply vanishes. At 60 degrees, the poles bake under continuous summer sun while the tropics freeze in prolonged darkness. Every ecosystem on the planet is calibrated to the rhythm that stable tilt creates. Agriculture, migration patterns, ocean circulation, all of it runs on seasonal timing. Strip that away and you are not just changing the weather. You are dismantling the biological clock that life on Earth has kept for hundreds of millions of years. The moon was never just a light in the sky. It was the anchor holding our world in place. Without the moon anchoring Earth's tilt, the planet wouldn't just lose stable seasons, when it would lose the very concept of predictable climate. Earth's axial tilt could drift anywhere from nearly 0 degrees to over 60, and it wouldn't take centuries to get there. Within tens of thousands of years, the shift would be dramatic enough to rewrite every ecosystem on the surface. At 0 tilt, the equator bakes under relentless direct sunlight, while the poles freeze in permanent, absolute darkness. Flip towards 60 degrees, and the tropics experience months of total night followed by months of scorching, unbroken day. Agriculture as we know it would be functionally impossible under those swings. You can't plant a crop when you don't know whether next year brings a frozen wasteland or a desert. Civilizations are built on predictability, on knowing when to plant, when to harvest, when to prepare for winter. Strip that away, and survival itself becomes a full-time, desperate calculation with no reliable answer. Here's a thought that rarely gets enough credit. The moon didn't just shape our future, it built our entire past. Without that gravitational anchor steadying Earth's axial tilt, our climate wouldn't have settled into the reliable rhythms that agriculture depends on. Farming requires predictability, and the same seasons returning year after year, generation after generation. Take that away, and the Nile floods unpredictably, the monsoons shift without warning, and the harvest becomes a gamble. No civilization can survive long enough to win. The ancient Egyptians tracked the moon to manage their calendar and coordinate their crops across thousands of miles of river valley. The Babylonians used lunar cycles to predict floods, plan wars, and govern their empires. Even the earliest human migrations followed coastlines shaped by moon-driven tides. Every city ever built, every empire ever raised, every written language ever invented, all of it rests on a foundation of climatic stability that the moon quietly provided for millions of years. Pull back far enough, and the moon stops being just Earth's problem. It becomes a question about life itself across the universe. Scientists studying planetary formation have found that a large, stabilizing moon like ours is genuinely rare, not something that falls into place by default. Most rocky planets spin chaotically without a massive companion to hold their axial tilt steady over millions of years. And stable axial tilt, as we've seen, is what gives a planet consistent seasons and a climate that complex life can actually build on. The hypothesis is called rare Earth, and it suggests that the conditions we take for granted here are cosmically unusual. A planet needs the right star, the right orbit, the right size, and quite possibly the right moon. Without something like our moon anchoring the system, evolution toward complexity may simply stall. That means the moon isn't just part of Earth's story. It may be the reason that story ever got interesting at all. Weeks after the moon vanishes, the oceans begin behaving in ways that no living creature has ever experienced. The tidal forces that once pushed and pulled billions of tons of seawater simply stop, and the consequences reach far deeper than the surface. Ocean circulation depends partly on tidal energy to mix cold, deep water with warm surface layers. Without that mixing, the great conveyor belts of current that regulate global temperature start to slow and weaken. Over decades, cold, nutrient-rich water stops rising from the deep to feed the plankton blooms at the surface. Those blooms form the base of nearly every marine food chain on the planet, so when they collapse, everything above them collapses too. Fish populations crash, then the seabirds and marine mammals that depend on them follow. Meanwhile, stagnant deep water loses oxygen and becomes a dead zone that spreads across entire ocean basins. What was once a living, breathing global system quietly suffocates from the bottom up. By the time a century has passed, Earth is almost unrecognizable from the world we know today. The tides are gone, the currents have stalled, and the axial wobble has begun pulling the climate into violent new configurations. Coastlines that once supported billions of people are either flooded or stranded far from any functional sea. The ecosystems that evolved over hundreds of millions of years start unraveling from the bottom of the food chain upward. Coral reefs, already dead, take entire ocean food webs down with them in slow, cascading silence. On land, the shifting axis warps seasonal patterns so severely that agriculture becomes a gamble no civilization can reliably win. By 500 years out, the human population has fractured into isolated pockets, clinging to whatever stable climate bands still exist. 1,000 years after the moon vanishes, Earth still spins, still orbits the sun, still holds an atmosphere. But the intricate, layered system that made complex life possible has been quietly, irreversibly dismantled. Most people look up at the moon and see a decoration, something ancient and beautiful, but essentially passive. That assumption turns out to be one of the most dangerous misconceptions we carry. The moon is not scenery hanging in the background of human history. It is an active, load bearing piece of the system that made complex life on Earth possible in the first place. Strip it away and the tides collapse, the axial tilt destabilizes, the seasons dissolve into chaos, and the biological rhythms that govern nearly every living thing simply break. What this thought experiment forces us to confront is that Earth is not a self contained miracle operating in isolation. It is part of a finely balanced system, and the moon is one of its critical components. We did not inherit a planet that just happened to work. We inherit a planet held in place by a gravitational partner we barely think about. That changes how you should look at the sky tonight. Tonight, if the sky is clear, step outside and look up at the moon for a moment. Not as a decoration, not as a romantic backdrop, but as the ancient engine that has been quietly running your world since before life crawled out of the ocean. Every stable season you've ever lived through, every tide that shaped a coastline, every night that wasn't pitch black chaos. The moon made that possible. We built calendars around it, wrote poetry about it, and sent human beings to stand on its surface. But most of us have never once thought of it as something we genuinely need. This video exists to change that. The moon is not scenery. It is infrastructure. Planetary infrastructure. As critical as the atmosphere above your head or the core spinning beneath your feet. So the next time you see it hanging there, full and bright and seemingly permanent, remember what you now know. Nothing that massive, that close, and that essential should ever be taken for granted.